How many of you have tried HoloLens before? Oh, a bunch of you. Sweet. How many have actually access to one? Well, nice. So the first time I tried the HoloLens, I was invited, it was a build, and I was invited into a room. And there was an operator there, and he said, well, put on the HoloLens, and then you can walk towards the table. So I did, and from the table, a house rose up. So I can actually see a 3D model of a house standing on that table. Thought that was awesome, really, really cool stuff. But I felt I want to do something with this, right? So the operator said, yeah, so you can walk over to the computer that's standing over there. So, all right, I did. And on the computer, there was a 3D model, the same 3D model that was on the table. And he said, well, you can manipulate the 3D model on the computer. So I did. I took the roof and I dragged it upwards, and well, the 3D model on the table moved accordingly. Why am I standing here with the computer? Why am I not here, right? So I asked him, why I want to be here. I want to do something here. I want to grab stuff. And so he told me, well, just drag the mouse to the edge of the screen. So yeah, sure, I did. A little bit further. The mouse pointer is now floating in mid-air, and I can manipulate the house. So I stood there with the hovering mouse in front of me. I ran back to Jessica. Mouse, pointer popped, mouse floating. What the heck are you talking about? No, you mean mouse popped? I couldn't even make full sentences. That totally blew my mind, and that was the first time. I will get to the second time in a bit. This was a moment when I realized that this is technology that is going to change the world. This is technology that is going to be totally amazing, and this is technology that I want to and actually need to work with. Totally blew my mind. So what we're going to talk about today is HoloLens hardware. We're going to go into basic Unity. How many of you are Unity developers? How many have started Unity at any point? All right, awesome. And then we're going to build our first holographic app. So the goal of this session is to, you should get to know how to get started with developing for the HoloLens. So my name is Jimmy Engström. I work as a web developer by day, and together with my lovely wife, I run a company called Awesome Dev, where we work on future technologies. So our focus right now is HoloLens. We talk a lot of bots. Jessica is awesome with UI and UX stuff, so we also include that in whatever is the future, because we think that the focus on UI and UX is something that is going to come in the future, because it's the focus is not there yet. We're running a user group called Coding After Work in Stockholm, and a podcast with the same name. So if you want to listen to us babbling for hours, you can check this URL. And I'm also Windows Development MVP. But enough about me. Let's talk about HoloLens. So if you have any questions, we might be able to do it during the talk. Otherwise, we can just do it in the during dinner or afterwards. So let's dive right in. So the HoloLens is the first holographic computer. That's what Microsoft calls it. It's an untethered device. It is untethered. It also means that it has some downsides, because since it's untethered, it needs to have a battery. And the battery for the HoloLens officially it's 2 to 3 hours battery time. I would say it's 3 to 4, of course, depending on whatever you use it for. So those of you who actually have access to one, do you say the battery time is better or worse? Better? Worse? Worse? Really? So we demoed this for we have had our HoloLens for ever since it was released in April that year. Mm. We actually find it to work really well. Of course, depending on whatever you're doing. It has 1 gigabyte video memory, 2 gigs RAM, 64 storage. It's got Wi-Fi and stuff like that. It got Bluetooth and everything. But it is a full Windows 10 computer, which means that you will be able to run 2D apps like Excel, or you can do 3D apps like this cute elephant. The tracking is done by these 4 cameras. So these are environmental sensing cameras. So these are going to record everything in the room and calculate where you are in the room. This together with the depth camera, the gyro accelerometer, it makes up something called the IMU, the inertial measurement unit. So basically, it's going to figure out where you are in the room, where the walls are, where the floor are, where the ceiling is, and so on. All this data, and I'm talking about terabytes per second, is going to be fed into the HPU, the holographic processing unit. So this is going to crunch the numbers, figure out where you are in the room, and give you back a position, basically. The lenses are transparent, and it works like this. So it got 3 different layers, and it's going to bounce the light through the lenses and into your eyes. So, for example, this table isn't, well, I don't know, red? Would you call it red? Red? Orange? Sure. Orange. Let's do that. Orange. It's an orange table. Now, the table isn't orange per se. It's how this surface reflects the light. So the same ways these lenses works the same way. So they're going to bounce the light in the lenses. So if this table was a hologram, the light is going to get into my eyes as if it was actually there. Awesome technology. So let's talk about the elephant in the room, the field of view. How many of you have heard about that the HoloLens has really bad field of view? It's a bunch of you. Cool. So the reality is like this. You see about, if you're holding a piece of paper, A4 paper, arm length distance from your face, that's basically your field of view. Now, we have demoed this for like 3,000 people or something like that. About 70% says that I didn't even notice. 30% say, yeah, can't be used, it's awful. So far, we actually met one that has a HoloLens and says, yeah, it's a problem. And we know a bunch of people that actually has a HoloLens. Because you adapt. You realize, I can't see the full hologram. Let's take a step back. So I wouldn't say that it's a problem. So those of you guys who actually have one, how many of you think there's a problem? 1, 2, 3, 4. Yeah, of course. So there was a lot of hands up, so I assume that the rest of you think that it's not a problem. Yeah, but okay, all right. Yeah, but have you tried it more than an hour? Oh, it is? Okay, well, yeah, sure, all right. Oh, okay, it's fine as it is. I approve. So what you can actually do is you can make the elephant smaller, so it can fit into your field of view. And if you watch the really good applications or experiences, as I like to call them, they're always small. We're going to try later on a game called Roboraid, and you will notice that the robots that are actually coming out from holes in the wall are smaller than your field of view, and it works. Now you can also use something called well, it's called HRTF sound, head related transfer function. I always get that wrong. So basically what it is there are speakers mounted just on top of your ears, and it will give you a full 360 degrees sound. So even though your field of view is small, you're actually going to feel like the holograms are all over the place. When you try it in this kind of environment, a lot of people and stuff like that, you will probably not get the full experience. But it's really, really awesome. So what can we use? Well, we can use Direct 3D. We can use HoloJS. Unreal, I actually have a question mark there because there is a template for Unreal, but it's not an official template. It's someone else has done the template, so I actually have a question mark there. Yes. Sorry. Yes, the Unreal Engine. Orho Sharp you can use as well. It's kind of a new thing with the HoloLens. And of course you can use Unity. So this is Unity. Don't worry, I will get to coding in a little bit. So here we have the toolbar where you can move stuff, rotate stuff, scale stuff. You have the scene. This is basically whatever you're going to see in your 3D view. For VR, this is your whole world. For AR, you will actually see, well, you will only see this cube in this case. We have the hierarchy. So this is everything that exists in your scene. So by default, you will get a main camera, you will get a directional light. I have also added a cube. Then we have the project folder, and this is the folder structure on your disk. So this is going to, whatever you put here is going to be stored on your disk, and if you just drag something into your folder with the Windows Explorer, you're going to get it here. And then we have the inspector. So this is the last thing we're going to talk about here. This is basic. How many of you are Visual Studio developers? Not all of you. All right. So this is basically the property window in Visual Studio. Every game object with everything in Unity is a game object. Every game object will always have a transform, which is a position, rotation, and a scale. And then you can add other components to that, like this one, like a mesh filter, like a box collider, like a mesh renderer, stuff like that. Basically, this is the 3D model, this is the one that renders the 3D model, and this makes the 3D model hit stuff, or things can hit it. So when we talk about HoloLens, there are 5 important things to talk about. The first one is gaze. The second one is gesture. Then we have voice, sound, and spatial mapping. And we're actually going to go through each one of these. To get started, I actually created a site called holotoolkit.azurewebsites.net. I'm actually going to move this to Holo Mixed Reality Toolkit in a while. So basically, you just download this into Unity. It's going to pop up. The reason why I'm showing this like this, because this is going to take a while, and I've sped up the progress bar. as soon as it's done. And this is the fast one. Yes. Yeah, sure. Absolutely. I can definitely show you, share the links. Sure. So what we did here, we removed the examples folder because examples folder for some reason do not compile. There's actually one example that we can remove, but and the rest we're going to show you now. All right. So let's see here. Yes. It is not a Microsoft product. It's a Unity product. There's actually a company that does the stuff, and it's C sharp, but it's not. So I can actually let me backtrack. So Unity is a 3D engine with 2D capabilities. The really nice thing with Unity is that it's cross-platform. So you can develop on a Mac, you can and especially you can deploy it to basically any platform. Yeah, even BlackBerry. Let's see, I can show you. So I have just a few of them installed, but well, as you can see, there's a bunch of them. I think it's like 23 or something like that. Yeah. And it's free. Good point. You can actually there are actually three programming languages. It's JavaScript, it's C sharp, and it's something called Boo. Is it? Yeah, I think so. But basically, everyone uses C sharp for it. So all the examples are in C sharp and stuff like that. All right. So when we install the Holo Toolkit, or actually the Mixed Reality Toolkit now, you will get this menu. And here we have Apply HoloLens Scene Settings. So if we check the camera, you can see that the background is blue. We have a position that is 0, 1, minus 10. What we want to do, what the HoloLens is going to do, or what Unity is going to do, is going to put the camera on our head. And when we move with the HoloLens, it's going to move the camera. So we want the camera to be in the middle of our head. So we want it to be in position 0, 0, 0. So what we can do is we can use Holo Toolkit, configure, and apply HoloLens scene settings. So it's going to move the camera to the origin position. It's going to clear the background to black, because black is is basically no light, and no light is going to be transparent for the HoloLens. We also updated near clipping plane because it's no reason. We updated field of view. There's no reason to render anything else, and we're going to set the near clipping plane to I think it's like 0.85. Everything in Unity is meters, so it's going to be basically 1 meter. The holograms is going to stop render. Now, this is a setting that I would say depends solely on whatever you're doing. Because if you're doing something that flies around, it's going to be really discomforting to see something that is here in your face. So that's a good point. That's a good example when you should keep this setting, like about a meter or something. If you're doing something stationary that is going to sit on the floor, you might want to be able to sit down, watch it even closer. So it depends solely on whatever you're doing. All right. The second thing we're going to do, I'm going to save this. There we go. The second thing is we're going to do project settings as well. Now, I've already done that because, well, I have to restart Unity. But what it's going to do is going to make sure that all the files are in text mode. Default is binary text mix, but it's going to make sure it's text mode. It makes sure that the VR, it's enabled VR and stuff like that. And for the HoloLens, that means that the camera is going to move with your head. That's the only thing that the VR setting does. So what we're going to do is we're going to remove the main camera. And then we're going to go into the Holo Toolkit, Input, am I in the way? Prefabs, and HoloLens camera. I'm going to drag that one in. So the HoloLens camera is exactly the same as the camera, but it has a couple of other things as well. So if you check here, we actually have gaze controls. It gives us the possibility to use the arrow keys in Unity to move around. So that's done. Now let's add create 3D object and a cube. This is our game view. So this is basically what we're going to see. So the camera is really, really close to the cube right now. So let's set this 002, that's fine, and just scale it down a bit. And as I mentioned, everything is in meters, so this would mean that 2 meters from my head, there's going to be a cube. That cube is going to be 30 centimeters big. So if we start this, let's hope this works. Yeah. So if you check this, if I move back, the cube is going to get smaller. If I move side to side, it's going to, you will see the perspective and stuff like that. So this is what we need to do to set up the project. So now we actually, if we run this, I'm not going to do that, but if we run this in the HoloLens, there will be a cube, and I will be able to move around it and stuff like that. So let's go back. No, you don't need a HoloLens. Actually, for most cases, you will be able to do everything in Unity. There's also an emulator that you could use to basically deploy it to you take the you export it to a Visual Studio project, and you deploy the Visual Studio project to the emulator. And my PowerPoint totally died on me. Yes. I mean, the HoloLens is a mobile computer. It's an Atom 1 gigahertz processor, so yeah, my laptop is going to be fine. Let's see, restart program. So the question is there a limit to what you can do with the HoloLens since it's a mobile computer? Yes, it is. It's very obvious. You have to think about how many polygons you're using and stuff like that. You have to think about shaders and stuff like that. But the Holo Toolkit has a lot of these things already built in. So many things you will get for free. But yes, you have to think about those things. You cannot have a lot of stuff, a lot of holograms and stuff like that, but you can have more than you might think, I would say. I'm back. So what we did, we downloaded Mixed Reality Toolkit from holotoolkit.azurewebsites.net, and I'm gonna fix that so it's gonna be Mixed Reality Toolkit at some point. We applied the scene settings, we applied the project settings, we deleted the main camera, replaced it with a HoloLens camera, and we created a cube. That's our first holographic app. So let's talk about gaze. So gaze is basically going to be a ray from the middle of the visor straight forward. And that's your mouse pointer. So gaze normally means wherever you're looking. So that's not entirely true in this case. It's where your head is pointing. You will notice that there's going to be a little white dot with which you can move around. Then we have the air tap. So it's basically holding up your hand like this and click and up again. So it's not until you have a finger up again it's going to register, because this is going to be hold, this is going to be pan, this is going to be scroll. So down and up again quickly. We've seen them all. We've seen the Crazy Duck. We've seen Pac-Man. And my favorite, this one. We're moving every other finger than the one that I just told you. But the important thing is very large movements. That's going to work best. Then we have the bloom gesture. It's like this, and you open your hand. This is the start menu button. This is the way you close an app. This is the way you get the start menu, and then you can start other applications. There's also a clicker. Looks like this. So one thing that is important to remember is it doesn't matter where you're clicking as long as the HoloLens can know where your hand are. It's where you're looking that is the thing that you activate. So you look at something and you can click here, you can click here, it doesn't matter. So the nice thing with this one is that you can use this to scroll and pan if you like. Doesn't matter where. So this is really nifty tool. Since it actually has Bluetooth, you can use one of these. This is the Xbox One S controllers. These are the ones with Bluetooth. So if you want, you can use them as well. Now, let's take a look at what it takes to implement tap gestures. Let's go back to Unity. So I like some order in my life. So I'm going to create an empty game object. Visst ni ser inte skärmen. There we go. Let's do that again. Create an empty game object. I'm going to name it managers. And then we're going to add, let's see here, input prefabs and input managers. We're just going to drag that over to managers. We're going to make sure that managers is in the 000 position. And we're going to add a cursor. The cursor like that. We're just going to drag that one in. There we go. So if I start this, should be able to see cursor here. If I move outside the cube, it's going to be dot. So whatever it has something, a game object in focus, is going to be a ring or dot. So what you probably can't see on the projector is that down here it's going to be two hands. So if I press the shift button, I will be able to actually have a hand and I can click like this. This is going to be the same air tap gesture. So I can actually try all of these things in Unity, right in Unity. Let's see here. In the cube, we can add a script. I'm going to add the cube gaze handler, and we can actually add the cube select handler as well. So this is 2 files that I've written. How many of you, is there anyone that feels that C#, that's black magic? Okay, 2, okay. This is, I think you will follow along. It's not that advanced. So what you do is you implement an eye-focusable interface. That will give you 2 methods. It's going to give you on-focus enter and on-focus exit. The on-focus enter is going to run whenever you have something in focus, and on-focus exit is going to run whenever you have something not in focus. So what I'm going to do, I'm going to say game object, and game object is whatever game object this script is attached to. So in our case, the cube. I'm getting the component mesh renderer, and the mesh renderer is the one that is responsible for rendering the cube. And I'm going to say I wanted the material color to be red. So basically, when I have a focus on a cube, it's going to be red. And whenever I move my head out from the cube, it's going to be white. I also added the select handler. Works just the same. I implement the eye input click handler interface. And I'm going to say when it's on input clicked, I'm going to run the method select. And just as the other one, I'm going to set the color to, well, green. You can't see that, but green. So let's see if this is true. It's red when it's selected, when we have focus. It's white when I'm not focused, and I just accidentally stopped it. And if I press shift and the button, it's going to turn green. So now we have actually implemented our air tap. So let's go back here. So we created a empty game object. This is just to get some order to stuff. We added the input manager. We added a cursor prefab. We created a script that implements iFocusable and iInput click handler. And we added those scripts as components to our cube. That's all that it took. Now, when it comes to holograms and stuff like that, having a UI with your hologram is not going to be the perfect solution. But talking to your holograms, using your voice to interact with them, that's kind of cool. Since this is a Windows 10 computer, it actually has Cortana built in. It also means that almost everything in the HoloLens is controllable by voice. And of course, we want to have our application controllable by voice as well. So let's go back to Unity. So in our managers, we're going to add something called the speech input. Let's see which one this is. This is the source one. So this is going to be the one that is going to trigger all the voice commands. It's going to get all the voice commands and then distribute it into the rest of the application. So let's see here. Let's add a new keyword. Let's add drop cube. There we go. And then on our cube, I'm going to add a script. Cube drop. So let's take a look at that. So we have a method called drop cube. So what it's going to do is going to check that does the cube have a rigid body. Rigid body is the thing that is going to make our cube react to gravity. So if we have a rigid body, it's going to fall, basically. If it doesn't, well, by default, it's just going to hover in midair. So then I'm going to be able to say that, well, add a rigid body. If we do have a rigid body, just wake it up. And I also have, since this is a Bluetooth device, I have a keyboard that I can connect to it, and I will be able to say that if I press the R key, as in reset, I want it to get the rigid body and put it to sleep, and then put it back to its original position 002. So on our cube, we also need to add something called a speech input handler. So what I want to do is I want my cube to listen to the command I just added. I'm going to say the keyword, I'm going to listen to the keyword drop cube, and I want it to work both in editor and in runtime, and I want it to run a script on my cube located in my cube drop script, and I want the method to be run. The method I want to run is drop cube. Right, let's see if this works. So when I'm going to try this is going to react to my PC microphone. That doesn't always work. So let's see if this works. Drop cube. Yes. Actually, I think this is part of the Unity speech recognition, but yes. So how is the interaction between Visual Studio and Unity? Can I pop up a message box? No, I can't. Actually, Unity does have message boxes as well, but you have to pop up one of those. Yes. 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 You have to do everything inside of Unity. However, what is really cool is that you can put a breakpoint in Visual Studio and run here, and the breakpoint will be hit. So it's really good interaction between these two. Right, let's get back here. So we added the speech input source to our manager object. We added the keyword drop cube. We added a component speech input handler to our cube, and we added a drop cube script, and we mapped the keywords to the different methods. Actually, I'm not sure we're going to talk about audio. Maybe we can do that. I think we are pretty good on time. So let's see. So my cheat sheet doesn't include audio. So let's see how this goes. So the first thing, on our cube, we don't have an audio source. When I add my script called cube audio, we will actually get an audio source by default. And this is because this lovely feature require component. So on my script, I'm saying that I require a component called audio source. That's awesome. And this script is actually on trigger enter. So basically, if a collider triggers, so if something hits my box, it's going to get the audio source and it's going to play the audio source, but it's only going to do it once. Let's see, let's go back to Unity. I really hope I remember all the steps. We go to audio, drag in hits. There we go. We're gonna add another. We're gonna do a. So what we to get the trigger event, I need to have my box collider is trigger. Now, if it is trigger, it's not going to hit stuff. It's just going to react to well, I just hit something, but I'm still going to fall. So what we're going to do is we need to add another box collider. So we're just going to add a box collider like so. And let's add a 3D object, plane, move it down a little bit, and try plane. And I forgot something. I'm also gonna set the cube and the audio source to not play on wake. Let's see if this works. That's not one. Right. Drop cube. And the really cool thing with this is to get the whole 360 degrees sound stuff. The only thing you need to do is go into product settings, audio, and make sure that the MS-HRTF spatializer is selected. And also on the cube, or actually the audio source, make sure that it is spatialized. Then you will get the whole surround thing. Right. This is not part of the Holo Toolkit. This is Unity all the way, actually. So everything I've done with use the Holo Toolkit stuff, you can do everything directly from Unity. The nice stuff with the Holo Toolkit is, for example, if you're using spatial mapping that we're going to do in just a while, it kind of gets jittery. It's not a flat surface all the time. But with the Holo Toolkit, it's going to figure things out. It's going to be they have algorithms for that. So it's going to be a whole lot easier. Yes, exactly. All right, so let's go back. We added require component. We talked about that. We set the spatialize on the audio source. We check the audio and make sure it was MS-HRTF spatializer. Yeah, that was it. So next up we have spatial mapping, because the HoloLens is all about using the environment. And one company that does this really good is Lowe's Kitchen Designer. So think of it like IKEA for kitchens. So what they do is, I can sit at home, pin some stuff on my Pinterest. This kitchen I like, and this kitchen I like. Doesn't have to be Lowe's in any ways, but I like these kitchens. Then they use Azure Cognitive Services to figure out what kitchen in Lowe's catalog this is most familiar to, or it looks like. So when I walk into the store, I can just say, "Good evening, I would like a kitchen, please." And they put a HoloLens, and they know that, okay, you like these kinds of kitchens. So I can walk around in my kitchen. See, can I reach that? No, I can't. Usually I can't. And it also has the other way around. So when she looks at these doorknobs and she said, "Oh, these are awful," they can actually get that data, make sure that, oh, she has a negative comment on the doorknobs. We can stop the production of these, or we can make sure that the next catalog doesn't have these awful doorknobs, for example. Really, really cool. I actually think they're recording it and they're going through it afterwards. But it could use voice recognition, but I'm not sure that it's good enough. Hmm? It's definitely 3D modeling software. Unity is not the tool for that. So this is the game where I talked about earlier. This is the one that we're going to try to... there's a lot of glass walls here, so hopefully we can find some space to try it on. Now, when we got the HoloLens home for the first time, I tried this game. How many tried it? It's called Fragments. Bunch of you? Actually 2. 3 with me. So, if you haven't tried it, try it. It's all about, you are a memory detective. So you will be able to see fragments of people's memories. And the really cool thing is that, well, not a cool thing, it's a little boy that is kidnapped. And your job is to be able to find this boy. So this game uses your walls, your ceiling, your floor, and replaces some things, like a couple of bricks on the wall, a power what's it called? Power box, something. So you can actually open it and you can see that, oh, it's 250 volts, for example. And what you can do, you go back to the lab, and then you can see, yeah, let's remove all the houses that does not have 250 volts in them. And you narrow it down to find this little boy. So a little bit in the game where I'm actually standing in this boy's memory. I can see there's a hole in my ceiling. It's actually a hole. It's raining in from that hole, building puddles of water on my physical living room table. A little further in the game, there's actually, I hear a voice, and I turn around, and one of the game characters is actually sitting in my couch. Just as you do. And as a developer, how is this possible? I couldn't grasp it. So this was the moment when I looked like this. Again, totally blew my mind. And the really, really cool thing is that the people that made that game had put everything they learned, every code they've written, back into the Holo Toolkit. So we have access to everything. It's open source. We can do this if we like. So let's take a look at what it takes to use spatial mapping. Now this is some seriously hard code. Let's see here. So what we're going to do is that we're going to go into Holo Toolkit. Going to go into spatial mapping, prefabs, and we're going to drag the spatial mapping into managers. And I'm done. So let's see if we can actually demo this. Actually don't know which one of these. Oh, there we go. It's Holo 2. I need the other one. Actually, I have the app installed only on one of them. Yeah. You can't move things, or yeah. You can use occlusion though, so 3D objects can run behind stuff. Occlusion. There we go. There we go. There we have the cube. If I look at it, as you can see, it's going to be laggy as hell on this one. That is not my experience. So I can move around like this. Let's see. No. So let's see if this works then. Drop cube. No. Drop cube. This is the worst demo ever. Drop cube. This could be actually the wrong... Oh, this is the wrong one. Damn it. So what you should always do is to remember what you name stuff. Let's see which one it could be then. Oh, this was totally part of the demo. Could it be that one? It's not that one. Yes. That would be awesome. Have we uninstalled it? I don't think it's this one. Let's try that. Oh, it might be this one. All right. Drop cube. And it actually stands on the floor. I did not. Actually, yes, I did. Might be without the sound, that part of the demo, actually. All right, so the spatial mapping is finding the floor putting up a collider so that the cube is actually going to hit it and stay there. No, the plane. I removed the plane. Yeah, yeah. All right. We added the spatial mapping prefab to managers. That's all we did. So I would like to end this presentation with a quote from Terminator 2. There's no fate. The future isn't set. There's no fate but what we make for ourselves. And I mean, this whole thing is, no one is going to tell us what to do. This is up to us. We make the rules from now on. And hopefully, I've done a good job at showing you that this technology is amazing, that this technology actually will change the future, and that this technology is something you guys need to work with. Thank you.